Why are rare aeroids so dark and velvety? At the equator, the sun shines at its brightest and strongest. And yet, so many of our low light tolerant houseplants come from this stretch of Mother Earth. Beneath the sun's glare lies perhaps the darkest of all environments for plants: the tropical rainforest floor. Only about 3% of sunlight above is able to penetrate through the dense layers of the canopy, like millions of green umbrellas. Here in this gloom is where we will find many of our favorite tried and true houseplants, like philodendrons, monsteras, anthuriums. While the trees and tree climbers grow towards the bright, airy canopy above, others will spend their entire lives in the dark, humid, and breathless shade. It is this low light tolerability that has made many aeroids so successful and popular as houseplants. Tropical rainforests form a broad belt around the equator, the largest areas being the Amazon Basin in South America, the Congo Basin in Central Africa, and the Sunda Shelf in Southeast Asia. Days equal nights in length throughout the year, and constant high temperatures combine with regular heavy rainfall to give an atmosphere which, when inhaled, feels as if it contains more vapor than air. And believe me, I know. This heat and humidity creates the luxuriant growth we call jungle. Most velvet aeroids are in the philodendron and anthurium genera. These plants are native to the rainforests of Central and South America. The dense vegetation that makes up most rainforests has three distinct layers: the canopy, the understory, and the ground. The canopy is created by trees reaching over 100 feet tall. The soil is always shaded, and by comparison, very little vegetation can survive at ground level. Vegetation can grow dense along riverbanks, where the canopy is broken and plants can get a clear shot of the sun's rays. Plants can also grow more abundantly at ground level along hillsides and slopes. The steep angle of the earth thins out the canopy, and more sunlight is able to reach the ground. In fact, many anthurium and philodendron species are found along slopes just like these. For example, Anthurium papillilaminum is a terrestrial species endemic to Panama. While its natural range is very narrow, it has been spotted in abundance along the banks of the Panama Canal, as well as the steep slopes of the country's Caribbean coast. In the jungle, it's not just survival of the fittest, but also survival of the most opportunistic. Plant survival here depends on its ability to reach more sunlight or tolerate perpetual shade. Many terrestrial aeroids, like Anthurium dressleri and Philodendron gloriosum, have developed darker leaves that contain more chlorophyll to capture as much ambient light as possible. It's this extra chlorophyll that darkens the leaves. But not all aeroids are adapted to deep shade, and in fact need more light to grow. Philodendrons are famous for quickly climbing up the sides of trees. Even the name philodendron means tree lover. Their seeds will fall and germinate on the forest floor and creep along the ground in a juvenile form. That is, until it finds a tree to call its host. As it climbs the tree and reaches the understory, it senses an increase in light and puts out bigger and bigger leaves to capture that light. A variety of anthuriums, known as pendant anthuriums, do the exact opposite. They grow their stem down as they hang from the side of a tree. But when they produce berries, the seeds that fall to the ground quickly die in the deep shade and infertile rainforest soil. So how do they get up into the trees in the first place? These aroids have made their berries a deceptively enticing treat for birds and other small animals, which will help disperse the seeds throughout the understory. Initially sweet, then having a tart aftertaste, birds will usually spit out the seeds. And only those seeds that germinate on branches, tree trunks, and even the crevices of cliffs will persevere. And yet, even with all of these diverse evolutionary breakthroughs, many aroids share one competitive characteristic. Their leaves are velvet to the touch, with a beautiful iridescence. So, what's the point of a leaf feeling like velvet? Besides giving a plant lover the irresistible temptation to massage those soft, delicate leaves like a creep? No, there's certainly an evolutionary advantage going on here. So let's take a closer look. The velvety surface along the lamina, or surface area of the leaf, is photosynthesizing more efficiently. Photosynthesis is when the plant uses energy from the sun to create its own food. The rainforest understory light is constantly diffused and shifting. Microconvex cells along the lamina facilitate to capture these fluctuating rays. And any opportunity to capture this light is a golden opportunity. But it might not stop there. Velvet and matte leaf surfaces are also theorized to be a means of shedding water droplets more efficiently than glossy leaves. This would be a major advantage in these wet environments where fungi flourish. In botany, plant species within the same genus are grouped into sections. A large number of anthuriums are in the section Cardiolontium. Many of these are suitable ornamental houseplants or outdoor garden plants in tropical climates. The section is broadly categorized by having B chromosomes and often possessing these velvety leaves. Western and southern Colombia are particularly rich in section Cardiolontium species. The elegant fashion of the rainforest is in vogue. Perhaps putting the spotlight on the more glamorous side of nature will bring us closer to it. Humanity is a materialistic race. No use in denying that. So perhaps we should use times of interest in nature to bring a greater awareness and appreciation for it. The wealth of the earth is right before our eyes, and Mother Nature is calling us back home.